an arc is considered to be a function set of t, where t is a real variable with the real part x of t and imaginary part y of t. And this t is considered to be in some interval from a to b. The easiest way of imagining this t is to consider it as some kind of time. You can think of this as some particle which are positioned at point x of t at time t. So when t is equal to a, we are in the starting point of the curve. In this case, an arc. And when t is increasing, we will move along this arc until t becomes equal to b. Here we are in the end of this curve. So what you see is that the curve has some direction, and the direction is in increasing t. Here is some example. Consider the following piecewise description of an arc. We let a be equal to 0 and b be equal to 2, and we have the following piecewise definition of the arc. It is equal to t plus it in the region from 0 to 1, and it's t plus I in the region from 1 to 2. So let's try to describe this or illustrate this arc. Starting from t equal to 0, then we have to use this description of the function. So then the complex number we are starting in is equal to 0 plus 0I. That's mean the origin. So we are starting in the origin. Then we are increasing t. For example, let t be equal to 1/2. Then we have real part 1/2 and imaginary part equal to 1/2. And we are in this point. When we are in the point t equal to 1, then the complex number we are reaching is 1 plus I. So then we are here. So this corresponds to a straight line from 0 to the point 1 plus I. When t is larger than 1, we have to use this piecewise description. So let's see. When t is equal to 1, we are in the complex number 1 plus I here. So we see now that this is a continuous function. We have no jumps here. Therefore it is an arc. So for example, if then t is increasing, then nothing is happening with the imaginary part. So therefore we are moving along a straight line here until we reach at the point t equals to 2, and at this point set of t is equal to 2 plus I. So we end up with this point. So this gives us an example of an arc where you have a piecewise definition. Here are some some definitions concerning arcs. We call a arc a simple arc if it does not intersect with itself. Like the 8th number, for example, is not a simple arc because it's intersecting with itself. So a simple arc does not intersect with itself. A closed arc is an arc where the starting point and the end point are the same point. So, and a simple arc, a simple closed arc, is just an arc which is both closed and simple. So, like a circle, for example, it's a simple and closed arc. Okay, let's have another example. Here we have the arc defined by a set of t equal to the exponential function of it, and here a is equal to 0 and b is equal to 2 pi. So t, you can call it the time, is starting in at time t equal to 0 and ends at t equal to 2 pi. So let's see what's happening here. T equal to 0, what complex number does this mean related to set of t? Yes, when t is equal to 0, then we have e in I0, which is 1. So the complex number set of 0 is 1 at this point. Well, what's happening when t is equal to pi over 2? Then we are here. When t is equal to pi, set of t is then at this point, and moving to 3 pi over 2, we are in this point, and finally at t equals to 2 pi, we are in the same place as we started, namely in the place 1. So this is an example of a simple closed arc. Notice the direction of this curve, because the direction is in the way the arrows are pointing, and it's in counterclockwise direction. Here we have a similar example, but notice that the direction we are moving from t equal to 0 to 2 pi is the other way. So when t is equal to 0, we start here, and t equal to pi over 2, we are here, not here. So we are moving in this direction, and it's also a simple and closed arc. Here's another example, similar, but here instead of t we write 2t. So we have this set of t, this curve. Starting at t, let's see here that we start from t equal to 0. The a value is 0 and b value is 2 pi. So let's see what's happening here. When t is equal to 0, we have the same point as before, namely 1. But know that when t equals to pi over 2, then what do we have then? We are not in this point, we are in this point, because then we have the exponential function of I multiplied with pi. So I pi here means that we are in the point -1. minus 1 here. When t is equal to pi, we are here, which is in the same point as we started, but we are not finished with our curve because we continue with 3 pi over 2, and then we are here, and finally when t is equal to 2 pi we are back here. So we are going 2 rounds in counterclockwise direction, but this is not a simple curve, but it's closed because the starting point and the end point are the same, but it's not simple because it intersects with itself during this time from t equals 0 to 2 pi.